Good day, everybody. My name is Rian Finter. I am a solutions engineer working for Adaptive Computing. I'm also a director of post-sale support. All right, so what I want to do today is go through a process of showing you how easy it is to assist with moving your on-premise workload into the cloud. And I'm going to use a OCI Oracle cluster that is deployed in Ashburn, which is configured within our on-demand data center solution, as well as our on-premise scheduler called Moab, and the two are aware of each other. And where you have, for example, a backlog situation, on-premise hardware are fully utilized, then we actually, more workload comes in, and then it actually gets, bursted into the cloud, so that that workload doesn't stay behind, and the whole process of using a bursting cluster that the compute nodes are down, and you actually not paying towards those resources until there's actually workload that comes in. Right, so I'm going to go ahead and share my screen over here. Right, so first of all, I want to go into our as we call it, our Moab viewpoint. So that's the user interface for our on-premise Moab HPC scheduler. And it is actually also available fully within the CLI side, but you can do it from the user interface in this case. So right now you'll see there's no workload currently running. I have created a template job that script actually that is going to kick off some examples of on-premise workload being run, and then we're going to have some user jobs that's actually going to run as well. You'll notice that again from my viewpoint environments, this is my on-premise environment right now. This is my on-prem node, which has got 16 cores, and then we've got two nodes that my scheduler is aware of within the cloud through ODC and into OCI. Each node has got 4 cores. Right, and then I'm going to jump into just to show you where this is residing. And this is within my on-demand data center side that I've got an existing OCI cluster that's deployed. And before going through some of the details over here, I'm just going to drill down into it so that we start the process, and you'll notice how it happens, as well as how it is all automated. So right now in this cluster that's deployed in OCI in Ashburn, you'll see that my queue is currently empty. And you'll notice that my nodes are currently down, meaning my cluster is in a bursting state. 8 nodes is up, compute nodes are destroyed, and will only be started up when workload comes in. Right, so let's go back to my viewpoint side. Now I want to submit some workload from here, so you can do it from the user interface. You can use the CLI as well. And within this environment, you'll notice that I've got a job over here that says burst into the cloud from on-prem using OCI cluster. So I'm going to select this, and this is a script, as I mentioned, that's going to run multiple job submissions. And I'm going to go ahead and say, great. Now, on the right-hand side, you'll see that because it is seen as one script, it will show this as a one job that's actually submitting, although it will change. It will submit my workload. All right, so now it's submitted, and we can go straight into our workload environment where it shows me what's happening. Right, now, as I mentioned, so on-premise, this is my job that's actually showing, that's my script that kicked off. And now I've got my 4 jobs that are running on-premise. This is user CNTOS. And now you'll see that they have gone into an active state. So they have been allocated against my on-premise resources, each one requiring 4 cores or 16 cores. And I've got my 8 user jobs. So you'll see user 1 up to 8 that also submitted workload. Each one of these jobs require 1 core and 1 node. So my scheduler on-premise have now allocated my on-prem resources, meaning it's filled up my on-premise hardware. And now I've got 8 users also submitting workload. So rather than waiting for an hour for this to finish, or for a day, or for a few days, these have now been allocated or bursted into the cloud. You'll notice that it goes into a block state. And the reason for that is we put it into a suspended state because where it's going to run on my cluster in on-demand data center, my compute nodes still needs to be deployed. So let's go ahead and have a look at my on-demand data center side. Now, first of all, you'll notice that now I've got 8 jobs queued, right? Previously, there was 0, so my on-premise jobs that were looking for a resource have now been bursted into the cloud onto my OCI cluster that's running in Ashburn, and they will remain in a queued state, right? Because remember I mentioned my nodes were in a down state, and now we're actually busy deploying these 2 compute nodes. So on-demand data center has got a burst cycle that we check our queue, minus set to every 60 seconds. Jobs came in, say, all right, okay, so now we need to look after this, and we're going to start up these compute nodes. Now, as I mentioned, each one of these jobs require 1 core, 1 node, right? And between my 2 compute nodes on this cluster, there's 8 cores. So we're going to utilize all 8 of them. Now, you could have used maybe a job that requires maybe 2 jobs, each one still requiring 1 core, 1 node. Then, depending on which bursting option you choose, we will start up one of these compute nodes. And because that's required, right? And then 2 of these 4 cores will be used. In the meantime, there may be more workload coming in, and if they can fit on this available cores, it will be added to this node to run against it. And if there's more workload, we can start up a second node as well. Now, this is where the different, as we call it, bursting options. So there's 3 options. One is minimum, which means we run your workload sequentially. So you deploy your cluster, and then you put on the bursting. And using minimum, it will run your workload one after another. So even though there may be enough nodes to run all of that workload simultaneously, minimum means we're not going to do that. We run them one after another, so it's additional cost saving. And it will take a little bit longer, obviously. Using maximum bursting, it means getting things done as quick as possible. So maximum means I want to start up all available nodes so that depending on what's in my job queue, I want to take care of that and get it done as quick as possible. So that's what max means. We've also added an option called all, which means irrespective of what's in my job queue and irrespective of how big my cluster is and how many nodes, just start them all up, and we're going to get take care of all my workload. And as soon as you switch on bursting, your head node stays up and your compute nodes are destroyed, waiting for any workload that comes in. As we saw over here, workload came in, now they're queued, and now my compute nodes are being deployed. Typically takes 2 to 3 minutes for a compute node to deploy. Process that we follow, in the beginning they were down. Now we're actually busy deploying them. So you'll see on the left-hand side. And then the nodes goes into available state. And remember, I've got a burst cycle. So then with the next cycle, which is every 60 seconds, that workload in my queue will be allocated and my 2 nodes will go into a busy state. So as soon as that's in the busy state, then all my workload will go into a running state and my compute nodes will be busy. And obviously, as soon as my workload has been taken care of, it goes back into available state. Now, within our cluster configurations, you've got an option to set something called an idle purge. By default, it's set to 10 minutes. Mine is set to 2 minutes. What it means is as soon as my node goes into available state, workload done, no more workload, we're going to keep it up for 2 minutes or 10 minutes, depending on what you set. You can set it for an hour. It depends on what you want to do. And then if there's no more workload in that time, then we're going to actually start taking my compute nodes into an offline state. And the reason for offline, is in case there's more workload coming in, we can easily move it back into a available state and make use of it rather than being destroyed and redeployed. And now we'll see, then after offline, next burst cycle, we'll destroy them and they'll go down. Now you'll notice while I was talking, my 2 nodes went into a busy state, meaning they were made available and it's been allocated against my workload. We can see over here that all my jobs are now in a running state. All 8 of them, both my compute nodes have been deployed and now they're busy. So we're going to take care of this workload and then we go back into available state. And as I mentioned, depending on what your idle purge is set, it goes into offline and then destroying and then down. Meaning the whole process is automated. I didn't need to do this all setup from on-premise. Communication happens via on-premise scheduler with on-demand data center. And we deploy resources to run this workload. And the big thing, there's two big things around this, is it assists you a lot in managing your cloud resources, meaning you don't have to constantly go and check, oh, there's some artifacts still left and they've been there for a few days. On-demand data center takes care of that for you. Only the head node stays up, and that's typically small. And then the compute nodes remain down, destroyed, until workload actually comes in. Now, let's have a quick look at my workload over here. Now, you'll notice that previously these ones were in a block state. Now they're active because the communication went back to my MoApp scheduler saying, well, listen, okay, my compute nodes have been deployed. So these bottom four that has got a user of CentOS are running on-premise, and I've set these to run for an hour. These are all my user jobs that have now been submitted. You'll actually see that it shows a different user, and that's my on-demand data center user. And so all of them are now active. And if we look at our node list, you'll see that all my nodes are actually now utilized. They're busy. So we can look at our on-prem node. We can look at one of my compute nodes. So let me just drill down in one of these, all from your MoApp viewpoint environment. We'll see that over here it says that it's the resource manager's ODC, meaning from MoApp to ODC is actually being communicated bidirectionally. And over here we can see which of my jobs are running against a specific node. And obviously, if you go back, we can look at each one of these. And as I mentioned, that you can constantly keep an eye on this. So you've got to, as an administrator, you want to maybe keep your eye on this as it's running. You can have a look at the workload from my on-premise environment using the MoApp user interface. And keep in mind, whatever you see over here is all available on the CLI from MoApp, as well as my on-demand data center. If you prefer using the CLI, exactly what you see over here is available on the CLI. Obviously, it just looks differently, but it's all available. All right, so let's have a look again at my on-demand data center environment. So while this is running, just want to go through one or two few steps here. I'm not going to show it in detail, but the process we follow, first of all, you have to have a credential, right? Within the credential manager, you can either type in your credential details or you can upload the file you get from a service provider that allows you to deploy certain types of instances within the cloud. And then the next step is, before we configure our cluster, there's something called a stack manager. Now that's where we create the image that the cluster uses. So we've got a base stack that includes everything we require, as well as certain applications we started including. But then we can also start including additional applications. There's a specific application that workload from on-premise needs to run on, and then you have to make sure that that application is available within the image. Image runs about 20 to 30 minutes. It creates the image within the service provider, and then within our cluster manager, when we do a configuration, now I'm not going to go into detail on this. I'll just briefly show this. You choose your service provider, and there's some detail you have to fill in: name, operating system type, and then this is where that image that you did in the previous step is important. So that's where you specify that image name, should use the correct image for this cluster. So this is just the configuration of the cluster. And then obviously you go through the steps of selecting credentials, and you select a head node size, which could be a VM, a bare metal, the GPU, and then depending on each provider, different data centers, different regions, availability zones, each one is different. But for OCI, that's the options that's required. I mentioned the idle purge time. By default is set to 10 minutes. So that's how long we're going to keep the node up when my workload is done. And then you configure how you want to, how many compute nodes you want. Maybe I want, for this VM, I want maybe, let's say 10, and maybe I want to add a, let's say GPU maybe to this list or to this cluster. So I'm going to take a bare metal GPU 4.8. We've got MIG mode included, and you want to maybe include that. So this is how you configure your cluster, and you can switch on bursting at this stage or afterwards. And you save it, and it's as easy as when you've configured your cluster, it will be down, go on the right, and you say deploy. Easy as that. All right, so let's have a look at our cluster, how it's currently running. it's possible that my jobs have started completing. Yeah, we can see that our nodes are available. So if I look at my queue, all my 8 jobs I now have completed, right? You'll see it's no more running, all done. And we can look at my nodes. Currently, it's available. Now, remember, I mentioned the idle purge time, which I've set to 2 minutes. So we'll wait for 2 minutes. There's no more workload. Then we follow the process down again, meaning we move them into an offline state. So as I mentioned, the reason for offline is if there's more workload coming in, we can easily move it back into available and use it again. Next burst cycle, no more workload, we start destroying it, and then it goes down. Obviously destroying is a quicker process. So shortly we will see that this nodes will be destroyed. Now, in the meantime, we can have a look at our on-premise environment. Workload, you'll see all my 8 jobs have now completed, and my other on-premise jobs are still running. Remember, I set this to run for an hour. Then that's where the important part comes in. You may have these on-premise jobs utilizing all available hardware. In the meantime, I've got my user jobs that comes in. So, well, okay, we can run that at the same time and burst them into the cloud. Or even there's maybe a specific, let's say, an OCI bare metal device, maybe that's required for, a specific reason, or a GPU for AI processing, or whatever the case may be. So you can actually tell it go and run in the cloud rather than on-premise. We can see also, if we look at our, out of my nodes over here. So we'll notice that there's a filter option. So I'm going to just see specific nodes. You may have multiple nodes over here, so we can filter that. I want to see nodes that are just, between a certain amount of ports, for example. So I want to change this one to 4 and make that one 16, and those are the ones that's going to be filtered, right? So those are the ones that we started looking at. Right, so now you'll see that we only see what I was working on, my on-prem node, as well as my 2 compute nodes that's seen by my scheduler, and all my workload is being completed. All right, so now if we go back to our on-demand data center, you'll notice that now, after being available for 2 minutes, no more workload, now we're moving into an offline state. And with the burst cycle that mine is set to every 60 seconds, after 60 seconds, this is now going to be destroyed. Now we can see that they actually are being destroyed. So the whole process is automated. Remember, we looked at it as it came in from on-premise, started up the computers, run the workload, all done. This is how long we want to keep them up, depending on, let's say, your batch run, for in case there's more workload. And after done, we start looking at our idle purge time. We move them into offline state, and now we're actually busy destroying them. So this is going to take a short while. Typically, destroying is not a lot of time that it takes. And again, as I mentioned, your on-premise jobs that's using all the hardware, it's still running, but in the meantime, you've taken care of all of your workload. So we'll just give this a few seconds, and then it's done. And while that's happening, just that you know, the standard output, standard input files from jobs that run, we keep within on-demand data center, within the file manager, but we also write it back to the user that submits from on-premise. And you can also run workload directly on on-demand data center, meaning if you want to submit directly from here. Now you'll see it's done. So now our whole process is done. Workload is taken care of. Everything's sorted out. So I'm going to leave it at that. And if there's anybody that have got an interest in seeing much more detail, I can do a much more detailed demonstration or even a proof of concept. Let us know, and then we can discuss it. Thank you for your time. Thank you very much. Cheers. Bye.